Solve problem 2.9 from Microelectronic Circuits 8th edition by Sedra and Smith. Assuming ideal op amps, find the voltage gain and input resistance of each of the circuits. So there's 4 total. We're going to start with circuit A. So over here I've written down the ideal op amp properties, which will be important for this problem. And we'll kind of review them as we work through this problem. But this first one is pretty straightforward. We just have an input voltage, an input resistance. We have this resistor connecting between the negative terminal and the output terminal and our output voltage. So because the voltage is entering the negative terminal, we know that this is an inverting op amp. Again, because the voltage is entering the negative terminal. So we can define the gain G to be equal to the output voltage divided by the input voltage, or the negative division between R2 divided by Rin, where R2 is just this resistor here, connecting between the negative terminal and the output terminal. Sometimes people will also call this Rout. So Rout divided by Rin. So what's Rin in this scenario? It's simply just the resistor that's directly connected to the voltage and the input terminal. So here we have this 15 kilo ohms connected directly in between Vin and the negative input terminal. So therefore, Rin for this problem is 15 kilo ohms. And then again, we see RO here is 90 kilo ohms, so we can calculate the gain to be equal to negative 90 kilo ohms divided by 15 kilo ohms, which is equal to negative 6. Let's move on to circuit B. All right, let's solve for circuit B. Again, we have an inverting op amp, and it's pretty much the same as A, except we added this 15 kilo ohm resistance connected to this node at the output. So how does this change Rin and the gain? First off, what is Rout? Rout is still just the resistance connected directly between the input terminal and the output terminal. So we have this negative terminal, 90 kilo ohms, output terminal. So that's still 90 kilo ohms. What is Rin? Rin is the resistor connected directly between the input voltage and the input terminal. So again, still just 15 kilo ohms. But what about this 15 kilo ohms at the output? Is this doing anything? Look at rule number 2 for ideal op amps. They have 0 output impedance. That means that this resistance here is equal to 0. And because of that, essentially this 15 kilo ohms is just being neglected because it comes after this Vout. So really this is doing nothing. We can just neglect it. Therefore gain is equal to negative RO divided by Rin, which is equal to negative 90 kilo ohms divided by 15 kilo ohms, which is equal to negative 6 once again. All right, let's move on to circuit C. All right, let's solve circuit C. So again, we still have an inverting op amp. It's pretty safe to say this is very similar, except for now we have 15 kilo ohms attached to this node. So how does this change the circuit? Let me direct your attention to rule 3. 0 common mode gain, or equivalently, infinite common mode rejection. What this means is if I were to connect a wire between my negative terminal and my positive terminal, it would have a voltage difference of 0 volts, meaning I lose no voltage between the negative terminal and the positive terminal. And because we have infinite input impedance, this 15 kilo ohms is essentially doing nothing, because notice the positive terminal is connected to ground. So the positive terminal is just experiencing 0 volts. So if I'm kind of connecting this wire to here, we have 0 volts here. We're going from 0 volts to 0 volts at ground. And no voltage means no current. So there is no current going through this resistance. We can neglect it. Then this becomes the same circuit as A. So RO is still just 90 kiloohms, Rin is still just 15 kiloohms, and the gain is equal to negative RO divided by Rin, which is equal to negative 90 kiloohms divided by 15 kiloohms, which is equal to negative 6 once again. All right, then solve for circuit D. So very similar again, except we have this 15 kiloohms at this positive terminal. So how does this impact the circuit layout? Let me direct our attention to rule 1 again, infinite input impedance. That means that the resistance going into this positive terminal is infinite. And we notice that V at the positive terminal is 0 because it's grounded. So V equals IR, then we have 0 equals I times infinity. I is equal to 0 over infinity, which is equal to 0. No current means no voltage, means that this 15 kiloohms is doing absolutely nothing. We can once again neglect it. So we can continue with our evaluation. RO is connected from the input terminal to the output, 90 kiloohms. Rn is connected in between the input voltage and the input terminal, 15 kiloohms. So gain is equal to negative RO divided by Rn, which is equal to negative 90 kiloohms divided by 15 kiloohms, which is equal to negative 6. So it turns out for all of these problems, we got the same result for all of them, thanks to our properties of the ideal op amp.